This is a little deal I put together for you on electric power steering. I got tickled one time when I went out there and I gave these guys this, there was a kind of a late model, I think it was an '08 GM SUV. And I said, check the power steering fluid. And they looked and 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 could not find the power steering fluid anywhere. They knew it had power steering. How do you know, just looking at it, if it doesn't have hydraulic power steering?
Wow, power steering lines.
No power steering lines, no power steering pump, nowhere to check the fluid. Can't you look at the belts? Now let me ask you this, the power steering belt, a pulley, is a little bigger than the alternator pulley. So why is the alternator pulley smaller than the power steering and the air conditioning
So
pulleys?
to turn faster.
Are you wanting it to turn faster? Or what does a big pulley give you that a little pulley doesn't?
More torque.
More power. So basically, if you got to put up 1,500 pounds of power steering pressure, you need a strong pump. They also make electric power steering pumps for hydraulic steering. They don't have a belt hook to them. They just got a real strong motor in there that spins them. You know, but that's not what we're talking about here today. Electric power steering is more energy efficient than hydraulic systems and does not provide assist until it receives driver input. So your power steering pump is always pushing fluid all the time. Okay, so if it's always having to pump fluid, move fluid all the time, it's going to be using little energy in it. Have you noticed how the cars, even the front wheel drive cars, you know, well, like the way back in that '98 Crown Victoria out there, they did away with the fan that's driven by the water pump pulley
Yep.
because it's using power. Right?
Yep.
Have you ever seen a water pump? I mean, the fan clutch on one of those fans, the viscous fan clutch, where it's completely locked up? I mean, you'll see that sooner or later, and somebody will say, "My car is really loud and it doesn't have any power."
If you take them fans off, you get about 50 more horsepower.
You do a lot better without the fan. That's the whole point. All right. So anyway, so until the driver requires any power assist, it doesn't work. Now, if the clock spring is not put back on right, though, you will tear the clock spring. So the EPS can operate the steering gear. Oh boy, that's Tim. That's Cobb. Hey Cobb, what's up? Okay. Okay, I'll see you over there. So it can operate the vehicle steering gear independently from driver input if it needs to, and it lets the electric power steering perform a self-parking operation. You know those cars that park themselves? You just pull it up there and tell it that you want a parallel park, and it uses those sensors, and it'll just go right in there. You know, who in here cannot parallel park? Everybody can parallel. You can't parallel park?
I never do.
Never do? I mean, can you though? Could you if you had to?
If I had to, probably.
Oh, yeah.
I'm sure.
That's it, we're gonna set you up an exercise, and we gotta get her driving a stick up on the, you know. All right, so here we go. Here's a conversion kit for a '67 Mustang. Now this makes it a little easier for you to understand what's going on, because you were confused earlier. You see how the steering column goes straight through, and this is going in from the side and provides help? Even if this dies, you still got steering. That's the only way you can make that work, and it makes sense, you know. Anyway, that's a conversion kit for a '67 Mustang right there. All right. Of course, you got your electric torque sensor, send signal to the computer. This is sort of a generic, you know, hookup. This is, you know, it's a Ford thing, in this particular, you see it's a Ford steering wheel. Driver inputs torque the steering wheel shaft. You got electronic torque signaler. Then the computer sends torque command to the motor. The motor creates assist torque. And see, all of that's made down here on the rack, which is sort of bulky, I think. I mean, I kind of like it when they put it under the dash better myself, like that thing right over there. Give me that thing right over there. Zach, bring it to me. That thing. Yeah, bring me that. Now this one here come off of, I think it's an '06 Pontiac G6. That's what we pulled off one of those. And all that. This kind of goes in there to the side and helps it turn the wheel and all that, you know. And these things have a tendency to die. They're made by Delphi. And whenever they die in a peculiar way, where sometimes you'll be driving it and you'll have really good steering, and then without warning you won't have any power steering at all. You'll have to fight it. But looking out there on the steering rack down there, there's nothing except just a plain old steering rack. And the electric assist is provided by this, you know. So that thing right there, that's about $500 and something if you want to buy one. A1 Cardone rebuilds them, you know. But anyway, the rack and pinion does the driver torque. You know how all that kind of stuff works. But see, your electrical energy is indicated by these arrows here, and your mechanical energy is indicated by the, you know, other. All right, so here's your pro and con. So here's another style right there. There's a bunch of different ones of these that I'm going to be showing you. And so we're going to let that fade out. An electric power steering system will maintain assist if the engine stalls while the vehicle's moving. Have you ever had the engine stall? You know, I like to tell a story about my aunt. She had bad power steering on her old big, years and years and years ago when the Piggly Wiggly used to be over where Enterprise Paint and Industrial is. And you would just pull straight off the street and park. It didn't have slanted parking place, you could pull straight off. And so she was trying to get this Oldsmobile that she had, that the steering had gone out on it. And she pulled it up in there. Of course, my aunt, the way she does, if it, you know, doesn't work right, she just keeps driving as long as she can, you know. So anyway, she pulled it in there and she angled it across 2 parking places. And my aunt is unflappable. You know what that means? No matter what happens, she doesn't react very much. So this guy rolled the window down and he says, why didn't you just take 3 parking places while you were, you know, he yelled at her because he was planning to park next to her and she blocked him. And so she got out and closed the door and says, no, I think those 2 I have will be just fine. And so she walked over to the store. The thing about it is, whenever the thing dies, you know, you're sitting here fighting the wheel. You know, if it's a skinny woman, she's going to have trouble, you know. Or if you're Jonathan, he may have trouble too. But anyway, if electric power steering shuts down while the engine's running and the vehicle's in motion, though, a driver could lose control. And that's what I was talking about goes on with these. You know, they don't lose control, they just have to be ready to apply some strength. And I know a few people that can't afford to get their power steering fixed. There was a recall on those. But if it was not covered under the recall, even though it was still dying, you had trouble. So the primary purpose of the electric power steering controller is to provide motor control. And the controller processor output drives 3 pairs of transistors that control the rotation of the motor. Now, if Adam was in here, he'd be interested in that because he's all about transistors right now. But this tells you how much that weighs and the size of it and all that. You know, there's a bunch of people that have been fooling with this power steering. What do you see here? Jonathan, you see the steering column coming through and the motor coming in from the side, right?
Yeah, see, the way I thought it was this right here.
That was your steering, yeah. Wouldn't that be terrible? Drive-by-wire, okay. So you got some inputs here, all right. Input to the EPS module, you got a torque sensor, you got a steering wheel speed and position sensor. That's 2 different sensors, right? Okay, so it needs to know where the steering wheel is, and it also needs to know how fast you're turning it, and it needs to know how hard you're turning it. Well, the torque sensor is basically giving it information on that. So you got rotor position, motor voltage, motor temperature, and then the controller's also got adaptive memory and diagnostics. Adaptive memory is what? What's the clearest example you can come up with of what adaptive memory is? Where's the most common thing you use adaptive memory on a car? Adaptive memory. Give me one thing adaptive memory is used for that you can pull out of the top of your head.
Radio? Radio?
Well, that's not exactly what I had in mind, but I suppose if you set your stations, that would be, that's an interesting concept. I'm talking about something that learns by itself.
Throttle position sensor.
Sort of does that. What about your fuel trims? That's adaptive, right? What about your idle air control? That's an adaptive learning thing. So they're going to have adaptive stuff here too. So you got adaptive memory and diagnostics. So you're going to be able to talk to the controller with the thing. There was this one girl that brought this. She bought a little 05 Chevy Cobalt that had been parked in a barn, and it didn't have a 50,000 miles on it. And it was a crazy thing, the way that the problems it gave. And it was the weirdest thing I've ever seen, because all of the controllers were trying to be all sluggish and didn't want to work half the time and all that kind of thing. And you really couldn't see a whole lot of anything wrong as far as wires or connections or anything, because the car looked like brand new. But whenever you could start it up, and if the network went offline after you started it up, you couldn't switch it off. I mean, you could turn the key, but it would keep running and stuff like that. And it would give you a network message, but it also had a power steering problem. and it was a power steering failure, and you couldn't turn it. But that one was covered under the recall, so she got that took care of. But anyway.
What was wrong with it? Not cutting off.
The network, that's what I started to say, the network on that damn car, the more we fooled with it, the more we cranked it up, the more we worked on things. And we didn't really do anything to keep the network, but it was like all those computers sort of decided they would start working. You know, everything just came back alive, and it would, I mean, over a period of time, it had been setting up for like 2 or 3 years. You know, and I can't remember, it seemed like we had to put a fuel pump in it, but other than that, that network just woke up all by itself and started working again. It's like the cobwebs, the electronic cobwebs went away. I don't even know if anybody else would claim that was possible, but I saw it happen on that car, because I said, we're going to track down all these network problems, but as it turned out, the network problem just slowly, over a period of 4 or 5 days, while we were fooling with everything, all those network problems went away right with their self. We didn't do anything to fix them. Now this is a block diagram. You see, you got your steering angle sensor, got an 8-bit microcontroller, got your torque sensor, differential Hall. It's giving your speed, torque, steering angle. How fast am I turning the wheel? It obviously needs to know that. Why? If you're going to take evasive action, it needs to know that I got to turn the wheels quick, right? That's something you don't really think about, you know. Sensor interface, that's an optional thing. And this right here, you got a tracker here, you got supply, integrated circuits, 8-bit microcontroller, 1632-bit microcontroller, and this is on your CAN and LIM transceiver. This is the CAN bus, high-speed CAN bus thing. Okay, and then basically you've got another integrated controller. There's a lot to this, and these are the transistors that drive the motor and make it happen. See that? In your rotor position, in other words, it needs to know where the rotor is. So there's a heck of a lot of engineering that went into this. You know, whenever you're going to do something like electric power steering, there's a lot more to it than you think there is. There's a lot of stuff in there, and all of this is in this one doggone box there. That controller right there is built in, and the motor's bolted onto it, and all that. So anyway, right here you got a 4.8 volt signal. You got a wiper sensor film, 5 volt reference, and you got ground. See how that wipes across there? All right, and then this is a sort of a similar thing to what I was just showing you. You got little drivers there. These look like little AND gates to me, which if both of those are energized, it shoots something out, but if only one of them is, it doesn't. There's your transistors there. You know, there's 6 transistors on that thing. You see how this is another motor voltage and temperature. It's keeping up with that. And then there's your motor. And then basically your CAN bus and your RPM, ABS, electronic, you know, whatever, steering control. Okay, the steering wheel sensor provides input for both wheel speed and position while the wheel's being turned. Now some of them, see what the point is, it's got all this together. Some of them, they got it separately. The voltage dividers are made of the resistive material. Now, what else do you can think of that uses resistive material? Resistive paint. Anybody know? Everybody just hoping that I'll get through talking about this so we can go to lunch early.
Some oxygen sensor wires.
What about throttle position sensor? As you move your throttle position sensor, it's basically the voltage. You've seen it when it goes up, right? In other words, it'll start around with 1 volt. You move your throttle position sensor through a sweep, and the voltage goes up. That's resistive element in there. It doesn't have little wires wrapped around anything. You got resistive paint in there.
I thought you was talking about like wires or something wrapped in something like heat resistant or something.
No, this one here, like the basic, what we're wanting to do is we want to use resistive paint to see where this thing is going.
Yeah, where you know how you dim your lights and stuff in your dash?
Yeah, similar. I mean, that's a rheostat. I mean, you're thinking in the right direction. The signal ranges from 0.5 to 4.5 volts with a plus or minus of 0.3. All right, so here's what we got. We got a rotation input here. Now, I built this graphic myself. I didn't get this from somewhere else, okay? So this is my invention. Now, I did borrow the picture of the steering wheel from an online source. But when you turn the wheel, see how the voltage changed? But I actually showed it going, you know, when you turn it 90 degrees, it moves that much. But it actually, as you're turning it, it doesn't jump all at once. It's actually stepping up. I could have put a lot more time into this and shown you that. All right, see now, whenever it comes back around 180 degrees, you're basically looking at voltage down here again. See, that's one of the ways that you can, I mean, this particular setup that that I was studying about. See, I turned it back and it went back up here again. And then I turn it over there, and then you turn it here. And it can tell as you're going what's happening. You see what I'm saying? In other words, it knows which way you're going and how far you're going, which way you're turning it and everything like that. And I just put that little graph on there. Now the failure of the steering wheel sensor can cause a shutdown of assist, like I was talking about earlier, where suddenly it gets hard to steer, you know. And all that. So you got a torque sensor here. The torque sensor performs the same function as a torsion bar and spool valve in a hydraulic system. Okay, the electronic sensor uses a torsion sensor in the same manner as in the spool valve. There's different types of electronic torque sensors, and they're classified as contact and non-contact types. There's a little graphic up there, you know, that basically where you got that steering column. Okay, the non-contact sensor uses the magnetic rotor with a alternating pole pieces attached to the torsion bar. That's what a picture of one of those looks like. The sensor monitors a twist to the torsion bar by measuring the change in magnetic flux generated in the vein by the veins located in the stator rings. That right there are some graphics you can look up online on that. It'll give you a little bit on that. So that's basically, I bit the edge off of that graphic right there, but a contact type sensor's got a wiper attached to the torsion bar and the little voltage divider. That's what we was talking about with our little steering wheel and the black box and all that. The change in resistance is used to measure the torque applied to the steering shaft. Okay? Alright, so here's your motor, basically. On GM cars, when the steering wheel is turned to its maximum rotation and you're just holding it, the power steering control module will command the maximum amount of current to the motor. One of the things that I have a tendency not to like to do when I'm driving one of my vehicles is I don't like sitting still and turning the wheel with the tires on the ground. Why is that a problem?
What's
Puts
more
too
wear
much
on the
more
car?
stress on it.
Yeah, and you know, it's really not too surprising when you think about all the years that Cadillac Eldorado pitman arm was having to work that center link back and forth when it finally sheared. Because, you know, when you were trying to turn those wheels with that thing sitting on the ground, you weren't able to turn them because it was so doggone heavy. It's just real hard to turn. And that pitman arm, that one little pitman arm thing was having to do that work. I mean, having to work really hard. And so if you, there's no use of putting undue stress on it. A lot of people don't even think about what's going on underneath. You know what I mean? Now, the ones of us that know a little bit about transmission and drivetrain and all that kind of stuff, we know better than to floorboard the accelerator and then drop it in drive, right? That's not really a good thing to do, is it? I mean, well, you know what I'm saying? I always think about it. When I'm shifting gears on a stick, I'm always trying to make sure that I don't put a lot of stress on the drive line. You know, I feather the throttle and the clutch and all so that there's, when it changes, it's a smooth transition instead of going bam, 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 you know, and slam.
What about, you know how there's some of them old Chevrolet transmissions, the valve body would stop up in them, they'd rip them wide open, slam them in drive,
Yeah.
and they'd clean it out.
Yeah, sometimes this one guy that I knew over there at the Lincoln place in 1984, whenever he had one that the governor was stuck on the back of one of those Fords because they had the governor bolted right around the output shaft so it could spin. If it wouldn't shift, he would get back there and get a hammer and bang on the drive shaft. Bam, 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 and it would unstick those things. So there's all kinds of stuff. Now on the old Edsels, they had the push button shifter in the middle of the steering wheel, and they had an electric motor on the side of the transmission to change the gears. Sometimes you'd have to bang on that electric motor up on the side of the transmission so it would put it in gear, you know. But anyway, but basically this was a couple of little designs that they were coming up with for the motor, possible setup for rotor position detection. You know, they wanted to know where the rotor is. Let me ask you this. How does, you know, when you get in the car, how many of you guys have got in a car out here that you're going to pull in here, when you crank it up, it starts moving the seat and you think it's going to ram you up against the steering wheel? Yes, it's pretty scary, isn't it? So how does it know where it was?
It remembers it.
I mean, how does it store that information? Huh?
It doesn't have to be like that.
Well, it's not adaptive necessarily. It's something that the owner, the person that's driving with fob number one, like Mama's fob, what she does is she runs it up and she sets the, you know, she sets it. So this is where I want you to be. And on a lot of these really high dollar cars, it'll actually move the mirrors, it'll change the radio station, it'll change the outside mirrors, and it'll move the seat, and it'll move the steering wheel. All that stuff moves around. There's a steering column up there that came off of a Lincoln that was set up that way. It's got two motors on it. so that it automatically can move that. But what it does is, every time if you look at the little, if you get an oscilloscope and you look at a motor, it's gonna have little commutator pulses. And what it does is it's got a microprocessor that remembers how many pulses, even if you move the seat all over the place. You know, it's gonna remember, it's gonna count and remember. And then whenever somebody gets back in there and mama hits her fob and said, I just recognize that code as mama's fob, I gotta put it where mama wants it to be. And everything goes back, it counts the pulses on that little commutator. So it doesn't really need a sensor in most cases. Anyway, there's a couple of little setups for rotor detection. If the steering wheel though is held in a position for a long period of time, like I was talking about, the PSCM will go into overload protection, power steering control module, and it'll basically, it'll try to keep from destroying itself because it's got some expensive repairs that have to be done. Okay, so you got a network connection here. See the network connection? And that's basically what that looks like. We looked at that earlier. And so basically you got that. What about this here? You got 40 volts on that one right there, the way that they were designing it. That right there was from an engineering thing that somebody put out about electric power steering and all that. I just wanted to show you all that. On a GM, if there's a high system temperature and the overload protection mode is invoked, you'll get a DTC C0176. What does C stand for? Hello? C? What's C stand for?
Chassis.
Very good. She was thinking. See what I'm saying? System thermal error. On some problems, the DTC C0476, electric steering motor circuit range performance may be set. Those DTCs indicate normal action, reduce steering assist to prevent thermal damage. So it's going to give you less steering to protect itself. Now that's the GM way. You know what I mean? The vehicle's going to protect itself even if you die. You know what I mean? I mean, you may die, but the vehicle's going to protect itself. All right, so diagnostics will require an examination of the total integrated system. You got to look at the whole thing. This is the thing. How many of you guys, when you're going to work on a system you've never touched before, go to the description and operation section of the manual to find out how all that stuff is wired up and how it works? If you're not doing that, you're dumb. Because you will be really surprised how many times when you go to the description and operation manual, you'll find out that either what they're complaining about is normal and you can show them in writing that it is, or you'll discover that, wow, I would have gone off in another direction with my diagnosis if I hadn't read that description and operation section. Because it'll tell you, when this happens, you can expect this, this, and this is what you need to check. See what I mean? Like a description and operation is the first place that a really good mechanic will go if they're working on some high-tech stuff in a vehicle they haven't seen before. You know? But anyway, wire and harness routing, electromagnetic interference can influence low voltage sensor inputs. If you've got a tiny whisper of voltage coming from a low voltage sensor and you've got something that's causing, you know, somebody's got some kind of big super duper something that's putting out magnetic pulses. Heck, if you've got speakers that are mounted too close, you may have issues with that. You know, that kind of thing. Connector integrity, moisture, corrosion can be a part of any system failure. And that's the end of the slideshow. Don't you like these short and sweet slideshows? Have you ever been in a class where the guy that was doing the class didn't have enough material and he talked really, really slow just to use up the time? Mm-hmm. Yep. Like tries to put 5 seconds between each word. Got that? Anyway, I told